In the last class, we had discussed about the resource allocation graph. If the graph contains no cycle, then the process in the system is not in deadlock. If the graph does contain a cycle, means a deadlock may exist. There are two cases, a deadlock may exist or the deadlock may not exist. Let us see a first case where the deadlock is going to exist. Here we have considered a graph, right? We have four resources, R1, R3, R2 and R4. R1 has one instance, R3 has one instance, R2 has two instance, R4 has three instance, and following with that we have three processors P1, P2 and P3. Let us see the cycle first. Now if we see, P1 is requesting for R1 and R1 has been allocated to P2, and P2 is requesting for R3 and R3 has been allocated for P4. Then P3 has been granted for R2. P3 is requesting for R2 and R2 has been granted for P1. Now if you see, there is a cycle which has been formed here. There is one more cycle which is present here where P2 is requesting for R3, R3 has been granted for P3 and P3 is requesting for R2 and R2 has been granted for P2. There is one more cycle here. Now here in this graph we have the deadlock. Right, because this R1 and R3 have only one instance. Now we will see where there is a cycle but there is no deadlock. Why? Because the resources instance are more than one. If you see here, R1 and R2 has two instances. Okay, if you see, there is a cycle which has been formed here. P1 is requesting for R1. R1 has two instances and R1 has been granted for P2 as well as for P3, and P3 is requesting for R2. R2 has granted the request for P4 and P1. Now if you see here, there is a cycle has been formed but there is no deadlock. Why? Because P4 is being allocated with R2 but P4 is not requesting for any of the other resources. As soon as P4 completes its job, it is going to release the resource. Now the resource can be allocated for P3. So though there is a cycle, the deadlock has not occurred. Okay. Next, we will discuss about the methods for handling deadlocks. There are, generally speaking, we can deal with the deadlock problems in three ways. The first one is we can use a protocol to prevent or avoid deadlock, ensuring that the system will never enter a deadlock state. That is, we are going to follow a protocol where we can avoid the deadlock there. The second condition is we can allow the system into a deadlock state, detect it, then recover it. For this, we will be discussing about the different algorithms also. The third one states we can ignore the problem altogether and pretend that the deadlock never occurs in the system. For example, in Windows and Linux operating system, this is what we are going to follow, where when the deadlock is going to occur, it is left for the application developer to write the programs to handle the deadlock. The simple method which we follow is we are going to restart the system. Once the system is going to hang, that means the deadlock has occurred. What we are going to do, we are going to just restart the system and after that we can continue with it, right? Now we will be discussing like how the deadlock prevention can be done and how the deadlock can be avoided. As we know, prevention is better than cure. We know like how the deadlock is going to occur. There are four consequences which should happen continuously. That is, one is called as a mutual exclusion. The other one is called as the hold and wait. The third one is no preemption, and the fourth one is circular wait. If we have all these four conditions, then we can say that the deadlock has occurred, right? Now, when we wanted to prevent any deadlock, we should make sure that any one of these conditions is going to fail. If any one of these condition is going to fail, then the one condition will be failed there. So if the deadlock has to occur, means all these 4 conditions has to be true. If we are going to make sure that any one condition is failed, means the deadlock is prevented there. The next one is called as deadlock avoidance. How do we avoid the deadlock? So it requires that the operating system be given advanced additional information concerning which resource a process will request. Like what is the need of the process, like what is the resource need for that process. It has to be informed, prior information has to be given and used during its lifetime. With this additional knowledge, it can decide for each request whether or not the process should wait. Suppose P1 is having a need of around 14 resources. Suppose there is only 13 resources which is being allocated, which is available, then there is no meaning in waiting for 14 process when only 13 resources are available, right? So when we have this prior knowledge, we can make sure that whether the process can wait and can wait.